AP Chemistry Stoichiometry Review, the mole. The mole is just a number, 6.02 times 10 to the 23rd. Entirely analogous to a dozen being 12, only much, much larger. Since it's such a large number, it is almost never, if ever, counted. Instead, it is weighed. And when it's being weighed, it's important to note that not all atoms have the same mass. Let's consider water. Here it is there. Notice how the oxygen atom is much larger. By mass, even though water has twice as many hydrogen atoms as oxygen, it is about 90% by mass oxygen, because the oxygen atoms are simply larger. We have to take this into account whenever we are massing out a substance. An oxygen atom is 16 times more massive than a hydrogen atom, and therefore if you want a mole of hydrogen atoms, that being 6 times 10 to the 23rd of them, you're not going to count them, you're going to weigh out 1.007 grams. This shows up under every element on the periodic table is its average molar mass, and it's how much you need to weigh out to have an equivalent number. If you weigh out 16 grams of oxygen atoms, you will have the exact same number of atoms as if you weighed out 1 gram of hydrogen atoms. They're simply smaller, therefore you can have more given the same mass. 16 grams of oxygen is a mole of it, and it's the same number of atoms. That's where it all begins. So it is just that number, and if we wanted to make water, we would mix hydrogen plus oxygen, and we could synthesize water. This is just burning hydrogen. In order to balance it, you should see that this is 2 to 1 to 2, right? 4 hydrogens on each side, 2 oxygens on each side, and if we wanted to mass it out, we would mix, well, I see 4 total hydrogen atoms there, and if I want a mole's worth, that's 4 grams roughly. 32 grams, 2 times 16 for the oxygen, and it will make 36 grams of water. As written, we are showing this combination. There's what we're starting with, our 2 pairs of hydrogen atoms, 2 hydrogen molecules, our 1 oxygen molecule, which is much larger. And if you're a visual learner like me, this should help. Here's what they look like when they rearrange. Let's show that again. The chemical reaction is a conservation of mass situation. Why? Because they're just rearranging. Nothing's gaining, nothing's leaving. Even if something forms a gas, it still has that same mass as it would if it were a liquid. It's just more spread out. We could also say that 2 moles of hydrogen molecules, that's 4 grams, combined with 1 mole of oxygen molecules, that would be 32 grams. To make 2 moles of water, that's 36 grams. That's our basic introduction to the mole. Our next review topic will be balancing chemical equations.